Hello and welcome to another video. In this video, we're going to be working on palindromic substrings. And in the problem, you're given a string S and you want to return the number of palindromic substrings in it. A string is a palindrome when it reads the same forward and backward. A substring is a contiguous sequence of characters within a string. So for ABC, there are three, A, B, and C, so one letter substrings do work. And for this AAA, there are six, so there's the first A, second A, third A, then there's these two A's, then there is the last two A's, and then there's the whole thing. So to figure out if a word is a palindrome, like let's say we have something like this. Hopefully this is a palindrome. It is. So let's make this bigger. So if we go through letters to figure out when something is a palindrome, our constraints here is 1,000, so we can have like an n-squared solution. But the problem with just starting at some index, like let's just say we start at this index over here, and we just check like, okay, we'll start here and we'll just like go through the word and we'll keep checking if it's a palindrome. The problem with this kind of strategy is like, let's say we're like over here, we say like, okay, this is a palindrome, this is not. There might be something down the road that is, even though your current word isn't. And so that's going to be really not great. So like RA might not be, but you can obviously add things to make it a palindrome. Like you can add AR and so on. So if you do this, where you just start at some letter and you keep going to the end, then your current thing might not be a palindrome, but there's always a way to make every single word that's not a palindrome at the end, right? Like let's say we have some random letters like BD. You can always make this a palindrome just by putting in the letters backwards, right? So DBAR. And so this is not super efficient. So ideally what we want to do is we want to have an n-squared solution that builds palindromes. But what we want to do to make it more efficient is if something's not a palindrome, we want to make sure that like ideally we don't build out farther, right? Like we check something, if it's not a palindrome, then we stop building out farther and we just end. And so the better way to do it, instead of doing it this way, starting at some index and like checking, okay, for R, let's just go through the word, then for A, let's go through the word, then for C and so on, is building out from the middle. Because there's two kinds of palindromes, right? There's odd and even. So let's look at an example of each. So odd would be like this race car thing. So if we have this race car, if we build from the middle, like let's just say, so what does an odd palindrome mean? That means there's something in the middle that can be any character, right? But then the left and right half are the same. So you can see for this race car, this E is in the middle. This can be anything. Like I can replace this E with any letter I want and it will still be a palindrome. But this and this are palindromes. So that's how you check for odd, and it's pretty easy to do so. So what we can do is we can just say like, okay, well, we'll just initiate this location and we will just build out from here. And as long as letters are equal, that's a palindrome. So like if we build out like this is a palindrome, right? Because these two letters are equal. So then we can keep going. These two letters are also equal. So this is also a palindrome, right? So CEC is a palindrome, ACECA is a palindrome. And then this is also a palindrome. But if one of these is not equal, then we don't have to keep building. So for example, if this A was AB, now we could say, okay, these aren't equal. So there's no point in building out because for a palindrome, every two letters that are like equidistant from each other are equal, right? That are as far from each other from the center. So like these two letters are 2 from the center. So they have to be equal. And if they're not, then if you keep building on this, anything else won't be a palindrome. That's why building from the middle is better. And let's take another example that's even now. So let's just say our word is like, well, let's just make up some word, right? So let's just say we have like AA, BB, CC or something, DD. Like this is our word now. It's even. So for an even palindrome, instead of starting at a arbitrary middle value that can be anything, now we can start at the two middle values. So we can start here and here, right? The left middle and the right middle. And let's get this one too. And for this to be a palindrome, all these have to be equal, and then you can build out the same way. So instead of having that one middle that can be anything, now immediately you can just check values, and if they're equal, then this is a palindrome, and we can keep going. So like AA is a palindrome. Then if these are a palindrome, we just made another one. Like if these two letters, all you have to do is check the current two letters, and you know everything in here is already a palindrome, so this was going to be a new one. So BAAB is a palindrome. Then we can build this out like this. and this whole thing is a palindrome now, and this whole thing is a palindrome. And same kind of thing. Anytime you're either out of bounds on one of them, or they're not equal, like let's say this was a Z. If this is not equal, then you can't build out anymore because these aren't equal anymore. So in order for it to be a palindrome, every two letters across from each other have to be equal, right? Same distance from the middle. So like the two A's are the same distance from the middle, the two B's are the same distance from the middle, the C and the Z are the same distance from the middle. And if those are not equal, there's no point building out because this Z and the C will cause it from not being equal. And same kind of idea if you run out of bounds. Like let's say you run out of bounds. Like let's say we start at like this letter. We're going to start at every letter. And we're going to try to get an odd palindrome from every letter, and then we're going to try to get an even palindrome from every two combination of letters. So if we start here, like this is fine. This can be a center of a palindrome. But then when we build out, like this is out of bounds and this is a B, so they're not equal. So we can just end there. So if we go through this word, let's say, then what's going to happen here is we're going to go character by character. We're going to first start at the odd palindrome starting at this character. And then we're going to go to the even palindrome starting at this character and the character right after it. So we'll like compare those. If they're the same, we'll build out and so on. So for B, we'll start here again, both at B, then we'll do here, then we'll start here, then we'll do here and so on. So the idea is for every character, you check an even palindrome with that character and the one after, and you check an odd palindrome with that character as the odd palindrome. And if that does work, like obviously for the odd palindrome, you have to actually extend out because any letter can be the middle. But like if we extend out here, then you can see this is not. But if this was valid, basically at every single starting place, we just keep expanding outward until we get out of bounds. And so this is going to give you an efficient way to do this. So we can quickly go through this AAA example just to show what this would look like. So let's say we have AAA. Let's make this bigger. And let's kind of walk through this really quickly. So we're going to start with this. Right, we're going to start at the first letter. We're going to check, is this like, obviously it's going to be fine as an odd, but in order for it to be an odd palindrome, I guess one letter is included, right? So every letter can be an odd palindrome by itself. So this is 1, right? So we're going to mark 1. Then we're going to see, okay, can we expand this out? So if this was odd and we expand this out, this would have to go over here. And now this is out of bounds, so it's no longer valid, right? So we can't have an odd palindrome here, but can we have something even? So remember, to do even, we do the letter we're at and the one right after. So does this work? Yes, it does. So we'll add another one. Now we'll try to expand out to see if there's anything more. So that would be here. There's nothing there, so that doesn't work. So we got all the palindromes with the odd being here or the even being these two. Then we move over here and we see, can this be an odd palindrome? Yes. Can we expand out? Let's see. Yes, this does work again. So we have another one. Yeah. Oh, I think I actually forgot one, right? So it should be this one, this one. Yes, I did forget one. Because it should be this one, these two, this one, and this whole thing so far. So we have 4 so far. Then we try to expand out again. We can't because these are both out of bounds, right? So there's nothing there anymore that's odd. Now we try even, which is the current letter and the one after it. Is this a palindrome? Yes, it is. So we'll write 1. And can we expand out anymore? No, we can't because this is out of bounds. So then we finally go to our last letter. So we do the odd palindrome starting at this letter. Every letter can be a palindrome, so it's another one. We try to expand out. So expanding out would be here and here. That doesn't work. And then we try the even palindrome with the letter and the letter after it, and there is no letter after it, so there's nothing here. So we have 6 total. So that's kind of the idea. You want to build centers from the middle, and then that way when something's not a palindrome, you don't need to keep expanding out as opposed to starting from the front where something might not be a palindrome, right? Like PA is not a palindrome, but if we add AP, now it is. But from the middle, if BA is not a palindrome and we're adding to the sides, no matter what we add here, because this screws it up, it's never going to be a palindrome. So that's kind of the idea. So we can code that up. So we're going to have our result, and we're going to loop through every letter in S. And we're going to check both the letter and itself being the odd and the letter after it. So we can just say for left, right, in. We're going to check 2 things, right? The letter itself twice, which is the odd one, or the letter and the letter after it. And so we can say while left is in bounds, and right is in bounds, and the letters are equal, then this is going to be a valid palindrome, so we can just add 1 to the result. Then we can move, we're going to keep moving out, right? We're going to move the left to the left, and we're going to move the right to the right. Because whenever something is equal, like let's say we are on these 2 letters, this is a palindrome of length 1, these are equal, then you would extend these out by 1 letter each. So you're going to say left goes left and right goes right. And as long as they're in bounds and they're equal again, then you have another palindrome and so on. Finally, we can return the result. And there we go. So it's pretty much as good as it gets for this problem. Yeah. And so the idea here is, like I said, we made it more efficient because we didn't start at the start. The other problem with starting at the start is, let's say you start at the start, like you say like, okay, my starting letter is A. The problem is if like AB isn't a palindrome, then how do you know ABC is and so on? Like you can't check for it. So you have to be able to traverse and actually check, is your letter a palindrome? And in order to check if a letter is a palindrome, you have to actually compare a bunch of letters. So that would be like an n-cubed solution like that. I think you can do this in like other ways, but this is like by far the best way, I think, for these palindromes where you want to count them. Just start from the middle and build them out. Build out all the odds and all the evens. And so here we will have a time of O event squared, because we basically have a for loop here and then a for loop here, and this is just doing it twice. So we will, like, building an odd and an even is basically 2 times n, and we have to do that for every single starting character. So O squared, and also the nice thing is the space is O of 1. Notice we're not actually storing words, we're just storing indices of the letters we're on, and we're just comparing if the letters are equal. So that's the other thing. With this, you'd probably have to do something else if you started at the start, so that would be a lot worse. I mean, yeah, I think this is a pretty common problem, so definitely one you should probably know. Let's see. You know, it looks like it's fairly asked a decent amount. It's definitely one you should know. If you've never seen a problem like this, it is kind of hard to come up with. But now that you know that, hey, if I want to count palindromes, I want to start at the middle instead of the sides, you can apply this to a bunch of other more complicated problems. So hopefully this is helpful. And if it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.